Okay, so we can start now?
Yes, please. We are live, sir. We can start.
Okay. So good afternoon all. And I welcome all the speakers of this session. Actually, today that our speakers are going to be talk about the environmental best practices in pulp and paper industry. Just to give a little brief before starting the session by the individual speaker, like the pulp and paper industry today, if you look into that, it is projected a pretty good growth, which is projected at 7%. That means in the next 5 years' time, we may be adding around 5 million tons of the capacity. So it is a really a large capacity looking overall. So per capita consumption, that is moving from 13 to 17 kg. Whenever there is a growth comes, it is very good for the industry, but the growth has to come with a sustainable environmental performance. And the industry is continuously working on improving the environmental standards and the performance. There is also a change in the regulatory landscape, and the regulatory landscape has come with the real-time monitoring of the water discharge quality, your stock emission quality, and also there are a lot of regulations are coming on the solid waste disposal. So the industry is mostly look into the water pollution and the air pollution, because the mill which operates with the pulp mill, there are a lot of pulp mill generated water related pollution, and definitely the recovery emissions and the power plant emissions are also there in the terms of the SOx and NOx values. But industry is responding to it well. We need to be, the industry is looking forward that the future investment should be the more in the cleaner technology. In addition to that, there should be work on modernizing to the existing industry, which are currently giving a particular amount of the environmental value. So how the industry has responded, because if you look into that, the wood-based industry, they have created a very good wood, sustainable wood management, through the farm forestry. So that is being taken care. And the recycle grade mill, actually they are helping out the environment by collecting the solid waste and recycling, making the paper. Same to the agro waste, because the agro waste can be burnt and form a carbon dioxide. But when it comes to our mill, so it is the, like inside the mill in the water, there are a lot of work going on reducing the pulp chemical consumption, bleaching chemical consumption, our lime clean areas, the pesticizing and the lime clean areas, and also the odor and the volatile organic gases, what has been emits, that is collecting and firing it in the recovery boiler and the lime clean. So in the integrated pulp and paper mill, so that is also taking care of a lot of environment, in addition to a lot of actions being taken in the, like during the paper manufacturing, in the recycled fiber and handling the solid waste. Also, there are the good technology investment and also coming in terms of the water treatment. So there are the diffusion air system, there are moving bed bioreactors. So these are all the new technology on the water, so that the water quality BOD, COD is maintained and it is good for the irrigations. So with all these good things, let's start listening from our speaker. Our first speaker is Mr. Chandrasekhar, and I request Mr. Chandrasekhar to take over from here. The topic is environment-friendly bleaching chemical. So, sir, over to you.
Good evening.
Good evening.
Yeah, I'm Chandrasekhar. I'm from Brooklyn Technologies, Chennai. The company we've developed what's unique and very globally first of its kind technology based on the platform of probiotics. While we have many products for paper application, today specifically I'm going to talk about a product which has been developed for craft paper mill, the packaging paper mill, where we developed a completely eco-friendly product that replaces hazardous biocides and HIPO. So, yeah, next. So we are a green technology company. What we mean by that is that our products are completely eco-friendly and they help in reducing toxic chemicals that are used in manufacturing in many industries. And in many cases, we've also replaced toxic chemicals that are used. The technology is unique and we have patented it across the globe. And very importantly, we are green without the need of subsidies. What we mean is that while we offer sustainable solutions, they're also economically feasible. It doesn't mean that you're going to be adding to the cost. You'll be actually saving costs at the same time, you'll be going the sustainable way. We were established in 2012 and we started with applications in leather industry. Then we moved on to textile. And under the Pro Charter brand, we have products for paper and pulp. We've just entered the cleaning segment also, where we are offering products which are totally chemical free for application in home and institutional cleaning. So this is a very important thing to understand why we are very unique. If you look at any chemical, it's normally petroleum derived, which means crude oil, crude petroleum is the basic source. Extraction of crude is not an eco-friendly process at all. Then it goes to a petrochemical refining company. My first job was in a petrochemical company, and I know how polluting it is, both in terms of air, soil, water. It's a very polluting operation. And from there, an extract is taken, which acts as the raw material for the chemical industry. So that extract goes to the chemical industry, which is again a polluting industry, and it supplies us those surfactants, those anti-scaling, and those products which are produced through this polluting process, and then they are supplied to processing industries. We are totally different because our raw material is, first of all, completely organic. It's vegetarian. It's a mother culture, which is a powerful consortium of microbials. Then further, when it comes to our factory, our product, our manufacturing process is also completely green. We have no boilers, we have no heating coils. The entire production is under ambient temperature. And we don't have any emission in the factory. We don't send anything into the air. We don't have any effluent that is happening. There's a minimal effluent that's also recyclable and usable in the garden. And the only solid waste is plastics, which are sent back to authorized recyclers. So from the way we source the raw material, from the way we manufacture, everything about it is eco-friendly. So what is the process? This starts with the mother culture, which we get from our partners. And from the mother culture, we add biodegradable and safe ingredients, which goes through a unique fermentation process, which we call as a patented process. And then the final products are produced. The kind of biodegradable ingredients we add depends on the end products we need, whether they are a chelating agent, whether they are surfactant, whether dispersant. So that's why our unique technology is to make the end product using completely safe and non-toxic raw materials to produce an end product which is also very safe and biodegradable. So to repeat, the final product is a consortium of biochemicals. It's non-toxic, non-corrosive, fully biodegradable. It is not an enzyme, which means it can be applied at any temperature and any pH. It can be stored at ambient temperature, doesn't require any special storage conditions. It has a shelf life of 1 year. And most importantly, in every application, we just integrate it into your process. We don't need any special adjustment or process requirement at the customer end. As far as paper goes, we have a number of products. The first product and the one which I'm going to talk about is Prozol Plus, which is used in packaging paper mills. Then Pro Enviro is another unique product we're just launching, which all the other speaker also talked about, which will help in controlling those volatile organics.
Mr. Chandrasekhar, sorry to just interrupt. Are you using a presentation, sir, or because your presentation is not up, sir?
1 second, I'm just looking at it. Does it come now?
Yeah, it has come right. It has come now, sir. You can just put it in slideshow mode, sir. Yeah, now it's up, sir. Thank you.
So, sir, it has appeared, but I request you to keep the microphone close to you, so it will be better audible.
Yeah. So, going ahead, like I explained to you, the manufacturing process and the raw materials are all green. And as far as paper industries goes, we're going to talk about ProSolve in the next few slides. Pro Enviro is a unique product we're just launching, which is applied at the cooking digester stage. It helps in reduction of mercaptan sulfides and the volatile organics, while also acting as a aid. ProWhite is another unique product which is helpful in reducing bleaching chemicals like caustic and chlorine dioxide. ProBleach is for de-inking paper mills, which is an aid to improve the oxidative bleaching process. ProRB is a very unique product again, where when hydrose is used at the reductive bleaching stage, ProRB helps in reducing hydrose usage by at least about 30%. The next product in line will be ProCook, which will be a digester aid, which will again anthraquinone free and will be completely biodegradable. Next. Yeah, I'll be talking about ProSol Plus, which is a product specially made for packaging paper mills. What is unique about it is that being completely safe and biodegradable, it eliminates biocides and hypo, which is commonly used in these mills, and it results in reduction of volatile fatty acids by about 15 to 20% at least. It improves ORP and stabilizes it, which means the system is stable and the pathogens are in control. The sulfate reducing bacteria is also reduced or inhibited, which means hydrogen sulfide generation is less. All this results in total reduction of significant and almost elimination of order in the paper mill and a very good reduction of order in the final paper, which is a great value for the end customer. So the product that we supply to the as ProSol is a two-part product. The first part is 127, which is the consortium of probiotic beneficial microorganisms. The other part is the bio-based dispersant. They have unique functions, like I will explain now. The biodispersant, what it does is in an existing system, you'll have biofilms, which are formed by the exopolysaccharides of these bacteria. The biodispersant breaks it, provides access to the pathogenic bacteria. Then the beneficial microorganisms, which are part of 127, neutralizes them and then cleans up the surface. Once the surface is cleaned, a biofilm of probiotic bacteria is formed, which inhibits any further accumulation of pathogenic bacteria. So the system is completely in control in terms of accumulation of pathogenic bacteria. The other unique thing about this microorganism consortium, there are a couple of microbes which are capable of neutralizing sulfur-reducing bacteria, which means the H2S generation is neutralized, which is the major thing in terms of keeping the environment and paper mill order-free, and also reducing the order in the paper. So how are we different compared to biocides? Number one, biocides, the problem is the bacteria tends to develop resistance to biocides overuse. Whereas with ProSol, where you have a consortium of so many microbes, beneficial microbes, the bacteria will find it tough to develop any resistance. Secondly, when the starch is carried over, when residual starch is carried over the system, it acts as nutrients to pathogens. So they keep on developing. Whereas the biochemicals in ProSol not only break down the starch, but the beneficial microbes start utilizing them and grow and build a strong defense. Thirdly, biocides are not known to be very effective against sulfate-reducing bacteria, which is why packaging microbes create so much of order. Whereas our microbes, there are some of them which consume SRB as its energy source, which is why the hydrogen sulfide generation is significantly reduced. Lastly, because the water quality keeps on deteriorating in a biocide situation, you'll be adding a lot of makeup water, which is scarce today. Whereas with our system, with the water quality being better, you find that the makeup water requirement goes down, which is again a big advantage in a water-starved situation. How do we apply this? Like I said, the application is very straightforward. It doesn't require any change in your operating system or doesn't require any special infrastructure. 126 and 127 are applied in the ratio of 1:2. Normally in the pulper or in the machine chest, 1:7 dosage is minimum and is required only to make sure that the biofilms are broken. And the application may sometimes be at the kofta or at the size press, depending on the plant condition and the study we do on the individual plants. Now I'll take you through a typical case study, one of the many mills which are now using ProSol Plus across the country. As you can see, the ProSol Plus is dosed at the dump chest in this place, and along with 126 and 127 are dosed at this place. If necessary, we also dose at the kofta unit. What are the observations we have seen after just a couple of weeks? When we started, the ORP was negative. ORP moved to the positive zone and got completely stabilized in 2 weeks. The final paper order, which was there in the system, came down, and the environment in the paper mill, which was very bad, significantly improved almost to nil. The ETP water, which used to be very dark and contaminated, started turning towards brown color. We completely stopped the bursar and hypo, and we've seen a significant reduction in VFA. This is a chart which shows how the ORP changed. From negative, it moved towards the positive change, and then it remained stable, which is a proof that the pathogenic bacteria is under control with a stabilized ORP. All the mills that are using our products have shown a reasonable and significant reduction in VFA, which is a very important factor as far as the paper order is concerned. 15, 20, 30%. There were some mills which had huge accumulation of slime, as you see on the top. After Prosol Plus was used, the 126 and 127 combination, within 3 months, the slime got dissolved, and this was a clear operation in the mill. As a result, what happened? The runnability improved, and the mills had fewer breakdowns in terms of the operation. So the productivity of the mill was also considerably better, and the paper was also cleaner. So to summarize, what have we delivered as Prosol Plus? Apart from the fundamental fact that it replaces hazardous chemicals, we've eliminated hypo, we've eliminated biocide, we've controlled SRB, we've made the environment in the mill much more pleasant, we've reduced the order in the paper, BFA we have reduced, ORP has been stabilized, slime has been removed from the system, which means your runnability, your productivity is better. Because hypo can be very corrosive, this product will make sure that there's no corrosion, there's no scaling. So your maintenance cost, your capex is reduced, and overall, you're totally safe to the environment. This is in summary what Prosol is. And as a company, we are in India the only company as of last year to be certified at level 3 as far as zero discharge of hazardous chemicals is concerned. And we are REACH compliant, which is a Euro compliant, Euro norm. There are about 250 odd chemicals which are considered hazardous, and none of these chemicals are present in our product. And as far as paper is concerned, we are FDA approved also. And because of our unique technology and our green technology, we have won several awards for innovation. Parivartan Awards we won in 2015. We have been rated as one of the top 25 companies in the Asia Pacific in 2018 as far as sustainability technology goes. We are the finalist in IIA, which is the European Award for Green Technology in 2019 and 2020. So in short, Proclean is presenting you a technology which is green, which is economically feasible, and helps all of us to go towards the sustainability that we have all been talking about in this session. To go back to one of the slides I said, the government today is talking about electrical vehicles. Why are they saying it? Because crude derived products are dangerous to the world. So we are offering a technology which is going away from crude, which is greener, so that we will go towards bettering this climate change disaster that we are heading to. That's what Proclean is, that's what Prosol is. Anything from your side? Thank you all.
Okay, thank you, sir, for your lovely presentation. And sir, the question answer session is at the last. And I request Mr. S.K. Singh, the Senior Principal Scientist, CSIR Roorkee, to start his presentation on waste utilization techniques and valorization of paper industry waste in the sustainable building projects. Sir, over to you.
Yeah, very good afternoon. I hope my slides are visible.
Sir, slide is visible. Yeah, now it is in the presentation.
Yeah. Thank you. Mohanty Sahab, for giving us opportunity. I'm very thankful to that CII and Godrej GBC with IPMA, who is organizing this theme-based discussions. So I'm been talking today on sustainable utilization of paper industry solid waste in constructions, and you know that a lot of things has been particularly looked into the environment and other things, being building science and technology from the institutions. So we are utilizing whatever waste and other materials into the construction sector. So I have also focused with our some industry partner along with the government funding. So we started work. My paper is been on that introduction, what type of paper industry waste, how we have to address those problems, different issues, what we have carried out at CSIR, Central Building Research Institute, conclusions, and our recent publications in this area. So starting with that, maybe because that industry people are more aware, but as from literatures we have been found that this is the 15th largest paper manufacturing hub in the world, and it's contribute about in India 2.6 of percent, maybe more, what Mr. Mohanty was telling, and some bigger to smaller things having mills of 859 having capacity of 20.65 million tons, and it is been expected they are adding much more, 5 million tons more, and producing about 17 million tons of paper, boards, and other type. But the basic issues that because in generating good quality paper, boards, scraps, and other things, so we are generating huge quantity of waste or industrial waste in form of lime sludge, about 10 million tons, and also that boiler ash and coal ash is about 12 million tons from all over the India, and that these is being only 20% of lime sludge is being utilized for processing and again converting into that calcium oxide, and a measure of few about 30 to 40% of ash being used as a brick and other manufacturers, but majority people are dumping or using as a filling material. So being it is a big industry, and we have to look into the solid waste management in effective manners, and also because the Niti Aayog and our environmental bodies continuously focusing on that. So let's we look into that. We have a different type of industries. One is wood-based agro industries and waste paper industry. So we have mainly pulp sludge, ETP sludge, lime sludge, boiler ash, and different combinations and different characteristics. So we have to look into that. As I have told that it's been data, we have correlated that about 1 ton of paper generate usually about 600 kg of lime sludge and 650 kg of boiler ash and coal ash. So, and what is the problem? Because again it is been lime sludge, but being it is agro-based industry and the silica is being in a lime sludge, so that cost of energy again recovery from the recovery plant of lime kilns, that is being energy incentives, and people are not following that. So a lot of silica scaling and other things is getting more and more energy to convert into the calcium oxide. So and as well that we have a lime in cheap, so people are preferring and then dumping this lime sludge. So but nowadays that with the different environmental agencies, there is a high pressure to reduce those waste material as well as CO2 emissions and energy consumptions. So we have focused on utilizing paper industries waste into the building products, and I'm thankful to Mrs. Ruchira Paper Industries, who has come up and being our industry partner and continuously supporting to our research activities. I'm not going to that, but from environmental to land and our that landfill issues, from that percolations, leaching, etc., is being considered one all those major issues, where if you are going to mask or confine those material into the building products, so we are able to use in a better fashion. So we have, that expertise. We have developed cement-based bricks and paver blocks. We have lightweight burnt clay bricks utilizing de-inking paper sludge. we have developed with this. One is a calcium oxide based, means calcining and then using as eco-friendly white putty, also calcium carbonate, where as a filler. You know that all white putties is being produced, and they use dolomite. In place of dolomite, we have used more than 80% of this material. And also we have tried, and in some small level we have done in a composite cement, where we have gone up to 25% using lime sludge. Also we have developed nano silica through the boilerensis, and belite based clinker, means cementitious binder. Also recently we have worked on gypsum, where lime sludge. And with this we have been technology, we have a lot of publications to process know-how, and we have been to put a patent. One is under that in acceptance mode, and another is under process. So that we understood the problem of the industries, and we worked on different front with my team, and we have looked into that in raw, means as received lime sludge into building products, and as a, treating it, converting into synthesizes, and again in a binder, putty, burnt clay brick, nano silica. So all those effects has been carried out. I am coming with this. I'm not taking much because you people are aware how this lime sludge is being generated. This lime sludge is nothing but it is a calcium carbonate, and it is in a crystalline form. So until unless we are going to treat, or we are going to activate, this is no use, and it is not going to be reactive, because this is the prime concern, and why people are not able to use in a bigger way. And then this lime sludge can have two methods. If you can use into that different building products, or we should use a another that kiln, and where again we can found that calcium oxide, which can be reused into that converting green liquor, or our recovery from sodium hydroxides. And so that was that. And we have processed into this lime sludge how we can make it good mortar, concrete, wall putty, and cementitious binder. It may be as a composite cement, it may be as a belite cement, or as a gypsums and other things. So that was our approach. And also we have looked as a fine aggregate as a performance enhancer into the cementitious, ordinary Portland cement or any, because code allows this up to the 5% it can be added into that. And because it's I will show how it will be, it is a particle size is very smaller, so as a performance enhancers can be used into that. This is characteristics, physical properties, what we have found from our Ruchira plant, that color is being white to little bit of play, specific gravity about 2.2, LOI from 40 to 48%, depending upon the moisture content. pH is very high, 12.72. And if you look into the particle size, D90 is 68 micron, and it is quite meeting the cementitious binder. And so it will be a very smaller particle. It can be used as a performance enhancer into the cement also. If you look into that compositions, that is XRF studies, this calcium oxide is about maybe, because it is including the LOI also, because it is converting, it is a carbonate in a form of carbonate, and it's a calcium oxide and LOI. So about 40% and 45% is calcium oxide. So it is mainly consist with the calcite and kaolinite. So calcite means nothing but carbonate. I will show you with that chemical. So our main emphasis is that how we can use. So we have tried, and if you look into the morphology, it is the non-fibrous structures, as we know, and also it's not been added much. It is in irregular shape and in agglomerated unit, because that is the issue, because it can have to be de-agglomerate, and it can be used in a effective manner. And also by edex that we have shown in a different way. So that is mainly the calcium and little bit of silma and other ingredients are available. If you look its TGA and detailed thermogravitic analysis, so it's whole, that it's initially the evaporation of water and volatile compound, and mainly it's calcium carbonate convert into the calcium oxide and H2O. So those, if you can see here, it is visible quite. And if you'll go with that our Fourier transform infrared spectroscopy, so we can found that carbonate at about our 1421 and OH stretching at 982, and Si oxygen and Si bond as 1802. So that is been available and it can be utilized if we know its chemistry. What we have done, we have taken a lime sludge. We have taken that same industries from the fly ash and added, and I'm not showing because it is our patented thing, some chemical activating those lime sludge. We have using a homogenization plenty mixer, and then we are being in our block making and other systems. So we can able, if you look into the paver blocks, we have to add coarser aggregate, where into this for those we have only added a fine aggregate. So one small, that brick has been used with the 12.5% of cement, lime sludge about 30%, boiler ash about 12.5%, fine aggregate 45%, and chemical additives, one cheap we have developed, and we can achieve a compressive strength of brick about 15 MPa. If we can reduce the cement content, we can go up to the 10%, where we can achieve compressive strength of brick of 10 MPa, as well as water absorptions about 10 to 12. So it will be as per our requirement. Our in a block, paver blocks, we have used the cement 15 to 17.5%, and with the 15% of cement coarse aggregate, we have achieved with the 37.5. We are in the process of commercializing that with the Ruchira Industries. We have been some mixing modification is going on, and been having our plants for making bricks as well as. One issue has been observed, because if you are not mixing or activating it, your edges won't come in a proper shape. So that is the important things what we have to do. So other things also, we are going hollow blocks and other with these materials. One things we have carried out lime sludge taking, calcining those lime sludge and making calcium oxide, adding cellulosic polymers and other things, and all those additions we are making outer wall putty. Similarly, with the calcium carbonate and white cement based system, adding that about 80%, 77 to 80% of lime sludge into that, and adding white cement about 15 to 17.5%, and some additives. So we are being very cheaper about that. Our cost will be about only 55 to 60%, and so it will be a low cost material, where that industries will be nearby places. So that we have carried out. Also, we have developed those white putty into our laboratory, and in our buildings, in our walls. And this is been demonstration some 6 months before this second waves of corona. We carried out and along with the Ruchira Industries, and it was very successful. We are making in a bag form in a large scale for using in coming into the market. So those. I'm not going too much into the chemistry, because this is nothing but calcite and kaolinite. So we have to activate both the things, and we have to convert into different forms. So where we can go ahead with this one. Also, that if you look into that characterizations, how we have achieved a very low cost our nano silica utilizing this boiler ash, and it was costing some 26 to 25 rupees, where that in a market it is coming some 200 or so. And we have made with this low cost nano silica into our binder system, made with the lime sludge, and we have converted into the different type of mortars and other things. So this is a whole. I'm not going again towards more towards synthesis and other. This is the Solgel process. It is well established process, and all those activities we have carried out into the laboratory. And if you can look into that, our developed nanosilica, it is been spectra. If you look XRD, it is been amorphous because haziness is coming, and all those 2 theta is been, and it is mainly having a single phase amorphous nanosilica, and also with the FTIR analysis. So this is, that if you look into that, all that microsilicas are being separated, and we can use there itself at near paper industries to make our better strong bricks and blocks with the high strength brick and blocks using those. And we have carried out with the different blade, and we found that our F1 blade where lime sludge for one small cubes about 34-20% of this, and we can achieve a good our concrete system. This is, if you can look into here, it is visible into the thermal analysis here, that our this reactions is being taking place where our calcium carbonate is decomposing, and here that we are finding a belite type or more calcium silicate gel, so it is taking energy into that. So this is the best what we can achieve. I'm not taking onto this. And also you can visualize with the different our F1 here. If you can look into the peaks of walnites, belites, all belites is being converting into the F1 blends, means a different type. And we have done adding with that some activators like ground granulated blast furnace flex powder to make it more and more strengthful. Here, if you look into the heat of hydrations, if you look into that, this is the second one, is a very steep one and making more calcium silicate hydrate. So our blend, it is for F1 blend, and we have done a study, calorimetric study, and we have well convinced with this one. So this is the strength. We are achieving good strength with those up to different studies with the lesser and maximum utilizations of our lime sludge. That if look into that nano silica, for 1 kg nano silica will cost about 23 if you are making in the same plant as being more than 150 and 200 rupees a kg from the market. And also when we'll make our binder, so it's cost about 6 rupees as kg, and 6.65 in place of more than 7 rupees kg of ordinary Portland cement. And we can use in a different way as a edge receive, calcined lime sludge, and other using in different ways, so into the concrete. So this is our way, and we have done into this way. Here if you look into that, when we are converting nanosilica and adding into that, more calcium silicate hydrate phase is being generating as we are not been adding. So we can have benefits with those into making a high strength or better durable product with the lime sludge. Also, that different activities I told that we have carried out and made, and this is the different composite cement we have made, and we have found that sample 2, which is been about 25% of lime sludge and some calcine clay, 50% of our clinker, ordinary Portland clinker has been used. And this gives, I'm not taking much on that. Here, that denser structure, mainly, I would like, because it is given in my paper. So here we have compared the result with the ordinary Portland cement and our developed binder as a sample 2. And it was being comparatively the similar results we have found. Only, that because we are using a lime sludge and some that, with the chemical reactions and other things, our fineness is being increased about a specific surface, about 587 meter square per kg, and it is fulfilling both the criteria as per our Indian standard 269 and ASTM-C 150. So we can utilize without having a 25% into that. Also, if you look into the life cycle cost analysis, and it has been reduction in the CO2 about 51%, being it is a waste material, and abiotic depletion decreased to level by 50%, and other things, sulfur dioxide, azotes, and other reductions will be high. With this, I will conclude that we have done, because I have not shown, we made lightweight brick using this drinking paper sludge, and it was very effective, very prominent, and well appreciated, and we have made a small whole study, and this paper industry's lime sludge boiler as that our drinking sludge can be economically utilized into construction field. Also, we can go with the amorphous silica. We can go with the belite type of cementitious binder. We can go with the composite binders where 25%. Also, if it doesn't means, we can go 5% of a performance enhancer. Sometimes people has some issues that they have some free lime, etc., because cement industries doesn't want to have any free lime, as we are being in the Codal committee. So that won't be here. And if there will be some free lime, because you have to treat and remove those by accelerated method. And this is our papers we have, and it's a well reputed journal. So we have thermochemically activated sludge into productions of our sustainable cementitious binder, low energy cementitious clinker. We have utilized paper sludge, that is the drinking paper sludge, into making lightweight burnt clay bricks. It means different type of activities we have done. Our patent has been processed, and this has been submitted. One more patent has been finalized. With these words, I am thankful to the organizer, thankful to Mr. Siddharth.
Thank you, Professor Singh. In fact, it is a lovely, innovative presentation. There are two parts in the presentation. One, you are targeting the reduce the pollution caused by the paper industry. So utilizing the lime slogs and the fly ash, trying to make a brick. When this will get a commercialized, definitely it will bring a revolutions, that putty and this brick revolution in the construction industry. That is as a one part. But part two, what I am able to get it is our normal clay brick, because normal clay brick creates a lot of pollution, and really our NGT are concerned about the normal clay brick manufacturing. They are a large contributing to the air pollution. If this kind of brick comes with the patent and commercialized, so the normal clay brick that will get phased out. So we are not addressing the paper industry issue, we are also addressing the clay brick manufacturing issue. So that's a excellent presentation, sir. And now I request Dr. Jigar M. Jani, Technology Head, Green Pebble Technology LLP. And the subject is treatment at source to address environmental issue in large scope. So over to you, Jani, sir. So, Professor Singh, you can unshare your presentation. Sir, you can unshare your presentation. Dr. Saab, try for it, sharing.
Yes.
Yeah.
Am I audible now?
Yes.
And is my screen visible?
Yeah, it's your screen is visible, but your content has to come now.
Is it okay now?
Yeah, the content has come.
Okay, wonderful. Thank you very much. Thank you very much, CII, for giving me this opportunity to present in this wonderful, exciting session. Let me introduce myself. My name is Dr. Jigar Jani. I'm the founder and owner of Green Pebble Technologies. I have a PhD in membrane technology, and overall I have 15 years of experience in developing, making, and integrating different kind of membrane products for different applications. We founded this company in year 2015 with the mission to bring sustainability, cost efficiency, energy efficiency in water treatment. We are basically Ahmedabad-based company. We are having our manufacturing facility also based in Ahmedabad. We are developing different kind of membrane products, hollow fiber, flat sheets, membrane products ranging from microfiltration, ultrafiltration, nanofiltration. These are some conventional membrane products. Apart from that, we are also developing some new membrane products such as forward osmosis, membrane distillation, electrodialysis. These are the processes and technologies which bring higher sustainability for various applications. It improves water recovery, it improves energy efficiency, so on and so forth. We have in total 30 plus successful installations of our products and processes in this past 6 years. We have a strong IP portfolio for different membrane fabrication, membrane integration, module preparation, as well as membrane applications for various industries, including paper and pulp industry as well. We have, as I said, we are having a dedicated R&D facility apart from that manufacturing facility in developing and integrating such membrane products. But the core focus of our company is to drive sustainability, to drive reducing the energy consumption, reducing the chemical and consumable consumption, to improve water recovery for less capital investment and less cost of ownership. So I will go into detail with the challenge that our global community is facing. I don't have to stress that water pollution and scarcity is the biggest global issue, and considering the climate change, what we have seen this year.
Sir, sorry to interrupt. I think there is a dialog box or something that is open about the presentation, sir. If you can just close that tab.
Oh, okay. Is it okay now?
Yeah, and there's one more, I think, sir. On the top also, there's another tab that is open.
I'm not sure how to.
Okay, minimize. That's fine, sir. That is fine. You can just leave that. Now it looks better, sir. Yeah, you can continue, sir. Sorry.
Okay, yeah, good to know that. So yeah, the focus has to increase now from all the stakeholders, industry, OEMs, government, of course, is doing its part to recover and recycle as much wastewater as possible. Wastewater recycling is one aspect, but apart from that, recovering the valuable resources. We just can't let the valuable resources in the affluent water to go away, because that is money. Waste is not just a waste; it is a resource. In the coming years, more and more companies and more and more industries are going to focus on different aspects, business aspect as well as the technological aspects, wherein they will try to address the issue of recovering more resources or nutrient from affluent water, as well as to recover more water at a significant lower energy, because energy is the biggest aspect. It has to be more sustainable in every front. So our focus is basically that only. The last point says that there has to be an increased focus on resource recovery in addition to the recycled water at the significantly lower energy consumption. So that's what I mean. We are offering differentiated solutions. We offer energy efficient, advanced, low cost, and easily deployable water treatment membrane system. What are the different advantages? It has to offer, and it is offering for our system, less capex, less opex, low energy consumption, minimal chemical consumption. It is modular and easily deployable. Many of our plants are fitted in ISO containers, 20 feet or 40 feet containers that are already fabricated at our facility, hydro tested, and they are ready to be shipped on trucks to whichever remote location that are there at various part of the world. And most importantly, it should also not be burdensome to the end user. It should have the favorable life cycle cost. And apart from that, we are also now integrating many smart sensor and analytics with the Internet of Things IoT-based platform, so that these plants can be monitored and controlled remote by remote location. What are our products and services? As I said, most important is membrane portfolio that we have. MF, UF, NF, MBR. These are the conventional membranes. We are fitting those membranes into containerized plants. These containerized plants are for various applications like brine minimization, customized municipal and industrial wastewater treatment. I don't have to go more into detail because these are the standard products and services that many of the companies provide. But differentiated things what we are offering is the innovation and the sustainable products that we have. What are the different membrane-based products that are relevant for this session and for this particular conference that we are attending? So for paper and pulp industry, from our various membrane products, we can utilize for as simple as raw water treatment, whether it could be groundwater or river water, lake water. That water needs to be treated before it is being sent to inside the plant. And once the water comes out of the plant, it has certain contaminants into it. So that ETP wastewater has to be also treated. And once after the treatment, the brine that is coming, we call it reject or concentrate. It is very difficult to treat this reject or concentrate by any conventional technologies. So brine minimization or ZLD. Many of the previous speakers in the first session, they discussed about ZLD and cost economical aspect of ZLD, how to do that, how efficiently to do that. So we are addressing those problems as well in our solutions offering. And CIP system, utility water treatment, evaporator condensate polishing, resource recovery. So these are the different aspects which can be tackled by various membranes that we have. This is already I discussed. These are the conventional membranes that we manufacture in-house in India. Many of these membrane products, maybe many of you know or maybe don't know, but these membrane products, they are conventionally being manufactured by Western companies like GE, Dow, Toray. But very few companies are there in India who are manufacturing these products. We are proud that we are also part of Make in India as envisioned by our Honorable Prime Minister. So what is the current status in terms of effluent treatment and resource recovery? The brine or the reject that is coming out of various industries it's a big headache for many industries. You have to have the minimized waste generation at the plant, and there has to be very controlled discharge of this brine into the natural environment. Many of the state governments are mandating that they cannot discharge this brine directly to the surface water, or they cannot simply discharge this brine. So they have to do ZLD kind of process system, wherein they have to burn the entire bulk of water, and essentially they have to convert the salt that is there in the brine into some kind of a solid form. So, but everyone knows that evaporator and crystallization system are they are very capital intensive. They consume a lot of energy. They are also they use exotic metals like duplex, super duplex, SS316L. This is very capital intensive, very heavy burden on capex and opex. many industries, they don't prefer this, but they because of the limited technological options, they have to rely on such technologies. What we are offering is somehow we are reducing the burden on this evaporator and crystallizer, and maybe we can shrink to a significant manner so that the brine and brine management by this evaporator or crystallizer should be as minimum as possible, and it offers great advantage in terms of capex and opex. So what is this? How do we do that? How we minimize brine, or how we minimize the effluent that is generated in different industry? So we are bringing with new technology. We call it forward osmosis, wherein brine or any effluent that is having high TDS or high COD, BOD load or organic load goes into our system, and with certain energy input, it could be fully electrical system, or it could be thermal based system, wherein the heat from or waste heat from the plant or factory can be utilized, and with which we can recover significant bulk of product water. This product water will have TDS of less than 500 ppm, which could be easily utilized for any of the utilities. And the high salinity brine, or the concentrated or minimized brine, will have TDS of more than 2 lakh ppm or 20% salt, which could be sent to last stage evaporator, or simply a dryer system or a solar pond system, and there will be a significant reduction in having multi-effect evaporator or having bulk of crystallizer system. We have proprietary membranes and patented draw solution recovery system, which is very specific for this process. And then it is very flexible in terms of treatment objectives. If some companies say that we don't want to have ZLD, but we just want to have minimum liquid discharge, because the concentrate that is coming out of FO system or this SBS system has certain value, so we can also offer that flexibility that the reject concentration can be also handled in a much better way, or it can be utilized for additional resource recovery processes on the downstream side. It is in the modular fashion. It can be, various heat inputs can be considered. It can be fully thermal or non-thermal, and there are various applications, as I say. So what is forward osmosis process? I will go very briefly on explaining this technology. Osmosis is a very known process. We learned that in a 6th or 7th grade, wherein if the low salinity water is separated with the semi-permeable membrane with the high salinity water, the water has tendency to go from less salinity to high salinity to balance the salinity across the membrane. So that is osmosis process. In reverse osmosis, we actually go against nature. That's why it's called reverse, in which low salinity water, we are pushing it against membrane, so that water has to go through the membrane, and we recover product water out of it. So it is not with the nature, but we are going against nature. In the forward osmosis, we do nothing but just the naturally occurring forward osmosis process or osmosis process. But we do with the artificial solution that we are injecting into the forward osmosis system. The region where P2 is mentioned, that's where we have high salinity water, which is the draw solution itself, and the water will be recovered from your field to the draw solution. In the schematic shown in the bottom left, the recovery will be basically removing draw solution with the product water, and product water will be taken out, and the draw solution, the rejected or separated draw solution, will again go back to the forward osmosis system. It is simple, but require very specific know-how about the process, and that's what we have been able to do that successfully. And we have commercialized this process for many different industry, chemical, pharma, paper and pulp. We are already doing one pilot trial at CSSI paper mill. In the textile industry, in seawater desalination, this application has been proven, and we have done many commercial projects as well. So how the forward osmosis technology stands against conventional technology like evaporator. As I had already discussed, compared to if you consider energy consumption, the energy cost, you can see that there is a significant reduction. At least for the energy cost, the forward osmosis is offering at least 50% reduction in the cost. And in terms of capital investment, it is almost 70 to 80% reduction in the cost compared to evaporators, which is significant. So what are the advantages? As I said, because you don't have high pressure, you don't require high pressure pumps, and correspondingly, you don't require high pressure piping, SS316 piping, valves. So all those accessories will be entirely eliminated. Apart from that, because forward osmosis is being driven at the low pressure, there will be less wear and tear to the membrane system. In RO, you are operating at a very high pressure. So high pressure directly corresponds to high wear and tear, and there will be repeated CIP system, CIP process happening in the RO, which will basically remove the selection layer for the salt rejection, and which will eventually lead to the replacement of RO. And this happens just within 3 to 4 years. In FO system, there are no such thing happening because it is low pressure. So even if there are high amount of foulants or scaling precursors into the inlet system, it will not have the tendency to deposit directly on the membrane. Even if it deposits, these deposits will be easily removed by CIP or cleaning process happening, and it will be in RO system, because of the pressure, it will have irreversible fouling, while in FO, because of less pressure, there will be reversible fouling and your membrane will have longer life. Compared to reverse osmosis system, which is operated at 40, 50, 60% water recovery, forward osmosis can be operated at 70, 80% and 90% water recovery. That is another advantage. And when you don't have high pressure and when you don't have when you have higher tolerance for foulants or scaling precursors, the chemical use is also significantly low. While in RO, there has to be very strict protocol that has to be followed for inlet silica or inlet hardness or inlet fouling precursors. So for that, you have to maintain or you have to inject very exotic chemicals into the RO system. In FO, you don't have all those requirement, which gives you additional advantage of low operation and maintenance cost. And apart from that, what is the benefit in terms of recovered product water? As you can see on the right side, product water is of excellent quality and consistently we have got less than 500 ppm TDS. If for any of the utilities, the water requirement or the water quality requirement is even more stringent than let's say 500 ppm, we can we can offer technological solutions like electrodialysis or EDI or polishing RO, which will bring this 500 ppm TDS further down to let's say 10 ppm or less than 10 ppm. So these are the different pros and cons of forward osmosis technology. So I'll briefly discuss about what we have been doing or what we are planning to do with SSI paper mill. We have sent one pilot plant of forward osmosis technology. The idea is SSI paper mill, they have the EOP filtrate. This EOP filtrate is having very complex nature in the sense that COD is in the range of 1300 to 1500 ppm. The TDS is let's say 5000, 5500 ppm. TS is also high. So there cannot be one process which can be implemented into this. It has to be combination of multiple process, but it has to be more sustainable in the sense that it has to be offering less energy consumption, less chemical, less consumable, and less overall operation maintenance cost has to be there. So we had done for the forward osmosis process, we had done some cost benefit analysis for their EOP filtrate by running several projection analysis, and we saw that there is a possibility to have multiple benefits for the EOP filtrate treatment by doing EOP filtrate treatment at SPB. One of or mainly there are 5 benefits. By recovering bulk of affluent water, you are reducing the reliance on fresh water dependency. That is number 1 and the biggest one. Another one is that the EOP filtrate contain significant amount of caustic. So after recovering the product water, the FO will have concentrate or reject. That concentrate will have the caustic into it. That caustic again can be fed back to the EOP process. Then this EOP filtrate so far was going into the ETP process. So this bulk of water, you can imagine the volume is 2,400 cubic meter per day, 2.4 mld. Just imagine 2.4 mld of affluent not going into the ETP. That will give you a huge cost saving. There will be a huge reduction in the power consumption. I told you, right? Forward osmosis will give you the energy consumption of 3.2 kilowatt hour per cubic meter versus reverse osmosis easily operates on 5.76 kilowatt hour per cubic meter. And the reject of RO has to be also be treated by the multi-effect evaporator. While in FO as a single stage will give you low pressure operation as well as the reject itself is concentrated so that you are eliminating the entire multi-effect evaporators. And I already explained that less dependence on the consumable or chemicals for the FO process. So there will be a saving for consumable and chemicals as well. We did some back of the envelope calculations for business case development and for the savings for this particular system, and we found that certain investment they can get up to 6 to 7 crores of savings every single year, and that is like giving payback period of 2.5 years. So that is a very favorable situation. It brings the sustainability into the process to the industry. It reduces overall cost. It reduces the operation and maintenance, less investment, and I think it's a win-win situation for all the stakeholders. So this is the proposal that we have given. It is pretty busy side, but to make it simple, it is divided into 3 sections. One is the pre-treatment, that is involving bar screen, coagulation flocculation chamber, multi-grade filtration, because the EOP filtrate is also having temperature of 70 to 85 degrees centigrade. We have to put the heat exchanger. So everything before the heat exchanger is the pre-treatment. As you can see, the feed is total feed is 125 cubic meter per hour, TDS, COD, BOD, these characteristics. After some pH adjustment, coagulation dosing, it goes into the primary treatment. After primary treatment, and by reducing the temperature, goes to the secondary treatment. Secondary treatment will mainly comprise of moving bed bioreactor, MBBR, followed by activated carbon and micron filtration, and then to have the finished product before it goes to the tertiary treatment, we are putting into the ultrafiltration system. Because the TDS is low, we are initially feeding it to the 3-stage RO system, wherein the permeate water will have the TDS of less than 0.5 ppm, and RO reject is as you know, RO reject is having TDS of almost 55,000. There was no other technological option except sending it to multi-effect evaporator. That's where we are trying to put the forward osmosis. Forward osmosis will get you almost 80, 70, 75, 80% water recovery. The TDS less than 350 ppm, and final concentrate of entire process will be having a volume of 5 cubic meter per hour, TDS is 1,50,000 ppm, 15% salt. So this salt, this this concentrate, very minimal brine, can be sent directly to the dryer system or the solar pond, and we will have a very sustainable and effective process for the entire EOP filtrate. What basically we are achieving here is two things. One is we are recovering product water of very good quality, and the reject. So this reject will also have the caustic. So if this caustic can be again sent back to the EOP process, so you are also recovering, valuable resource of the caustic by this process. So we are doing this pilot. The pilot is already ongoing at the site. Will not go too much into detail, but basically we are trying to mimic the process that we are proposing to SPB, and the results will be available by end of this month or beginning of next month. This process, this pilot plant, we wanted to do in the month of April or May, but then the COVID strike and we could not do it. But hopefully by end of this month we will be able to do that. So I'll briefly give the overview about what we offer, what we do, and how it is relevant to paper and pulp industry. Membrane can be a very powerful tool in achieving the energy target, sustainability target, water treatment related goals. But in order to achieve that, you need to have, has to be capital. It should be favorable in terms of capex and opex. It should be easily deployable and affordable. It should not be a headache to the end user in operating and maintaining such system. We have already successfully proved this technology for various industrial water. We have done this for common effluent treatment plant in Gujarat, Tamil Nadu. We have done this for agrochemical industry, petrochemical industry, mining industry. But this is still a new process for the paper and pulp. We are already doing many things with the SPB, improving this technology over there. So it could be very interesting for many other paper industry companies to try and test such kind of new technologies over there. It also opens a broad window of opportunities. As I said, just not the water, but also many resources that are there in the affluent water that has certain value and which could be recovered, and it could also give some kind of a monetary benefit in terms of operations. These are many different clients that we have, and that's all from my side. Thank you very much. Any questions?
Okay. Thank you, Dr. Jigar. The question will be at the end of the session, the question answer.
Okay.
Thank you very much for lovely presentations. I think there are lot learning for every one of us who was watching the presentation. Certainly the paper industry, like the water is a important component for manufacturing paper, but day by day the regulatory is putting a cap on the water consumption. So then they are keep on reducing what you should consume per ton of paper, and paper industry is currently and continue to look for what are the opportunities to save the water. So one definitely point, takeaway point from here is many integrated pulp and paper mill, they have already found out the source and sink of the water, but they're not really know that what is the treatment to be done so that the pulp mill water can be used in the paper machine, or paper machine water can be used in the pulp mill, and a different, basically the need of different areas. Certainly this looking a very, very promising. And thank you very much for the lovely presentations.
Thank you.
From
Thank you.
here, I will move to the next presenter, Mr. Deepak Jindal. He is the General Manager, Environment, 90 Paper Mills. He will be presenting the green technology adoption at 90 Paper Mill. So over to you, sir.
Thank you, sir. Thank you so much for giving me the opportunity to present. I'll just share my slides.
Okay, sir, your screen is visible. Please put it in a or like a presentation mode.
Right, sir. Visible,
Yes,
sir?
okay. Yeah, it's
Audible also,
visible.
sir?
Yeah, audible.
Yes, sir.
Please go ahead.
Sir, Nani, just to brief about Nani. Nani is an agro-based paper mill established in 1995. We are manufacturing different writing and printing grades of paper, and during Corona period, we also started a job and craft. The total installed capacity of the mill is 310 tons per day. And we have reduced water consumption by almost 40 meter cube per ton of paper from the last 5 to 6 years, from around 80 meter cube per ton. Our main raw material is bagasse and wheat straw, and mainly bagasse we use because it is available almost 8 to 9 months with us. We have been awarded by Environment Award in 2005 by State Pollution Control Board and National Award for Excellence in Water Management in 2007 by CII. We are also having ISO certifications. Along with this, our ETB laboratory is annually accredited. I would like to share some of the technologies which we have installed to conserve water or reduce the wastewater. The first was the installation of highly efficient pressure shower systems on paper machine. These showers worked in the combination of air and water. So the water consumption in high pressure showers was reduced by almost 700 meter cube per day. From 2900 meter cube to 2200 meter cube. Similarly, we are completely recycling paper machine effluent to pulp mill. Not even a single drop of fresh water is being used in pulp mill. All this effluent paper machine backwater is being processed to save all. Approximate 70% of the bleach backwater is used in countercurrent washing in bleach section of pulp mill. They were reducing fresh water. We have also recently started special blend packing without sealing or cooling water in pumps and agitators, which is almost saving about 300 meter cube per day of fresh water. We are using foul condensate from soda recovery plant in ODL washers for pulp washing. They were reducing the fresh water. Also, we have installed this DCS-based biomethanation plant. It is an imported plant from Hydrotherm, Netherlands. The CO2 reduction is 80% and BO reduction is 90%. This plant is completely DCS-based. The methane production is, gas production is having a methane content of more than 80%. Next, we are using the ETP treated effluent for after secondary stage for wet washing of raw material and wet bulk storage. Since wet bulk storage gives higher COD effluent that is being treated in the biomethanation plant. Since last 2 years, we have installed a pilot project of 2000 meter cube per day to recycle the water. Since we are in Ganga River Basin, we are very much pressurized by the groundwater authorities and CPCBs and MOEF to reduce the freshwater consumption. So we have introduced this RO system followed by the mechanical vapor recompression system. Installation of RO system first stage does not involve much cost. The main cost is how to treat the reject. For that, we tried this mechanical vapor recompression system or low temperature evaporator. We are almost 99% successful in this technology. Only fine tuning is pending, and we are recovering 97% of the fresh water from the total reject at a cost of just 50 rupees per meter cube. And the reject generated is passed through ATFD, thereby getting a powder form of sludge which can be transported to the third-party recycler. This is the RO system we have installed. This is only single stage RO. This is the LTE or low temperature evaporator which we have installed to treat the RO reject. Also, we have installed ESPs in all our air emission stacks. Earlier stacks have been fitted with emission rate of less than 50, and new stacks have been fitted with emission rate of less than 30. Also, we are drawing groundwater from the bore wells. So we are having certain implications or compliances that we have to recharge almost 1.5 times of the water withdrawal from the ground. So for that, we have constructed these gabion structures in the rain drains in the upper hills of Nainital. So there we are almost recharging twice the annual groundwater withdrawal And we have installed piezometers over there. From the last 5 to 6 years, the groundwater almost increased 2 to 3 meters in that area. This is the rainwater structures which were constructed before rain. Since the soil is very loose in this area, so the water percolates very fast. This is the after rainy season. This is the current photograph that they are still being maintained on regular annual basis. Thank you, sir.
Okay, thank you, everyone. That's though we have started little late, but almost all we are 15 minutes just overshoot the time, and as the time is little overshoot, what we'll do, the question answer separately we will take with the participant, and just I have one or two questions. I would like to put these questions before closing it. The first question is for the Mr. Chandrasekhar. What are the chemical you have explained? Is it reduce the BOD, COD of effluent water?
Yes, sir. We have seen a COD reduction post about 6 weeks. Initially, the COD does not reduce, but it definitely reduces after about 6 weeks. And in fact, one of the hardwood mills where our product is running, they've also confirmed that their COD has gone down by about 15% when they're using our product. 1.5.
1.5. Okay. So see, whatever the COD reductions, if it is 15 also, it is a significant for the industry.
Okay,
And please, whenever you are interacting with the industry, share that the COD of effluent water can be reduced by using this particular chemical in addition to the odor, which is playing the bacteria and your volatile fatty acid reduction.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir.
And we have one more question for Dr. Jigar. Sir, this FO system, like in India, there is a large number of mill based on the recycled fiber. And the recycled fiber, there is no pulp mill. It is they use the waste paper, and then it goes to the effluent treatment, and subsequently that effluent get discharged. Can those effluent water be treated with FO? Have you ever tried it out, or have any knowledge about the water of the recycled paper mill?
Yes, sir. We have done some pilot studies about recycle, carton waste. There are in Gujarat there are many waste recyclers, and they generate lot of waste. So we have tested for FO for them, and the results were promising. As I said, FO process itself can handle high load of COD, BOD, and high TDS. So that is the potential of the technology. You don't require multiple unit operations to get the treatment objective. So far many technological providers or solutions provider or equipment providers, they were offering multiple unit operations, mainly because we were limited by the technology. FO has the potential that can have, that can handle high COD load and all the different contaminants as well as the high TDS. So of course you can do that.
Okay, I request with this, I will also request IPMA to pass this message to all the recycle paper mill, so that they can definitely work out their proof of concept. And this use of this technology will definitely help them to reduce the water consumption. And thank you. I have one more question. So what is the cost per meter cube of water for treatment?
So the cost can vary depending on the inlet parameters. But if you say, let's say TDS of equivalent to seawater, let's say 35,000 ppm, 3.5% salt. For that, the energy consumption will be 3.7 kilowatt hour per cubic meter, and depending on the electric cost, let's say if we talk about Gujarat, which is we have the 7 rupees per unit cost for the electricity, and for that it will per cubic meter cost will be 42 rupees, 45 rupees. So that's
42, 45.
here.
Okay, so thank you very much. Thank you, Mr. Chandrasekhar, Professor Singh, Dr. Jigar, and Mr. Deepak. And thank you, CIA, and for conducting this session. So thank you.
Thank you very much. Thank you.
Thank you, sir. Thank you.
Thank you all.
So I think we are all exiting now.
Yes, sir.
Okay.
Yes, sir. We are closing the session, sir.